Hi, I'm Shinyoung Yoon from Team JSSS. We are going to talk about our recommendation system today. First, to remind you about our project, let me explain about our topic again. Our topic is News Article Recommendation System. The main four reasons why we chose this topic are like this: abundant data, high accessibility, quick feedback, and daily actions. Our recommendation system shows personalized news to users by Android application. There are computed keyword data and recommendation algorithm on the web server. We made the computed keyword data by doing data pre-processing, which extracts the meaningful and important data in the news. All data which you and other users read in online news is carefully collected by publishing companies and broadcasting stations. It is called fresh text data or unstructured data. A lot of effort is put into the analysis of this unstructured data with the highest possible accuracy, as it is a key to the understanding of users' behavior. It is here where text mining comes to the stage. Text mining techniques extract meaningful information from news articles. Text often contains slang, sarcasm, inconsistent syntax, grammatical errors, and so on. While text mining discovers relevant information in the text by transforming it into data, the natural language processing transforms text with the use of linguistic analysis. So we use natural language processing tools. We use NLP implementation for Python NLTK and use other packages. The data processing will proceed as shown in the following figure. I will explain each step in the following explanation. First, we analyze the data file in JSON format. The following data is collected 1,000 times for each category. The data consists of each news article's category, headline, author, link, short description, and date. The category, headline, and short description alone are not enough to know the overall content of the article, so the article content was obtained through web crawling. Second, to pre-process data obtained by data file and crawling, the data have to be tokenized, cleaned, and normalized according to the purpose. Split each sentence to define a token in meaningful units. We use word tokenize and word punct tokenizer from NLTK. And then remove words less than 3 letters and remove stop words which interferes with the task. Next, it goes through process of finding lemma from extracted words. We imported word net lemmatizer from NLTK. We restored the original form of the verb and extracted parts of proper nouns and verbs from tokens. By checking the frequency of use of the classified words, 3 words with high usage frequency were extracted. These 3 words become tags that represent news articles. In addition, these 3 tags in each article will be used to measure similarity as described later. TF-IDF is term frequency inverse document frequency, a value that indicates how often a particular word appears in a document. For example, suppose you have the following document. You can calculate the TF by counting the number of times words appear in the document. You can also calculate IDF by dividing total number of documents by number of documents where the word appears and taking the logarithm of that value. Finally, we can calculate the TF-IDF value by multiplying the values of the two matrices. Based on the news title and short description, we created a sentence listing important words for each news article and saved it as a corpus.json file. We created a TF-IDF matrix through this process. We used TF-IDF vectorizer module to make the matrix. We calculated the cosine similarity using the previously calculated TF-IDF matrix to find the similarity between each article. Cosine similarity refers to the similarity between two vectors that can be obtained by using a cosine angle between two vectors. If the two vectors have exactly the same direction, the value is 1. If the direction are opposite, the value is -1. That is, the cosine similarity is determined that the closer the values are, the higher the similarity is. The following is the cosine similarity formula for two vectors A and B. Based on this formula, we calculated the cosine similarity between 1000 articles in each category and made a similarity JSON file for the category. Finally, if the category name and index of the selected articles are entered, the similarity between the articles of the input category and the selected article is returned. Now I will talk about our main recommendation algorithm. First, we don't have any data about the user. So we received the 3 categories from user and we can recommend random data in the same category in order of the rank. And we have to add random data because if we don't give random data, user will never read the news from another category. After they read some news, now they have history, so we can recommend with this history of user. First, we will sort the news order by the number of same category. So after sorting the news, we can choose top 3 category and we will use 2 methods. First one is for ranked news, which is in the top 3 categories, and second one is for the rest of the news. Let's see the first method. I extract the 3 news from second rank. With these 3 news, we compute the similarity with every news in the same category. After that, we will compute the total similarity to choose the news which is related with every news in the same category from user history. And we sort the data by descending order and choose the most similar news from the result. Let's see the second method. Now we have only few data which is not included in top 3 ranked news category. We have only few news in this category. We will compute the similarity separately. In the same way, we sort the similarity and choose the most similar news. So in the final result set, we have result of method 1, result of method 2, and random data. Because of the same reason with explicit method, we should put random news. To use this recommendation system, we need the web server to communicate with Android application in real time. So we use the Flask web framework with Python and we communicate with JSON form. The server has 2 requests. The first one is explicit recommend. If the server receives user's favorite category, we will send the recommended news list based on user's favorite category. Second is implicit recommend. If the server receives users' history, we will send a recommended news list based on it. Once you start the application, you gotta choose 3 categories you like. They will be ranked based on the order you click them. Of course, you can change your choices. If you are done with choosing categories, the app will recommend you some articles that you might like based on your choices. You can read the articles by clicking the news card. You could get some other articles by clicking the refresh button on the top left. Once you read 10 or more articles, the app will recommend news articles based on your recent 10 history. We asked some of our friends to give some feedback. They said that the biggest advantage of this app is that they can choose what they really want to read. There are some possible enhancements. Because of lack of time, we asked our friends to give some feedback. We could quantify those feedback from users by adding like or dislike buttons and save the quantity of like and dislikes on the web server. Since we use our laptops for computation, it took huge time cost to compute all the 200,000 data. Therefore, we reduced the data to 41,000 data, which is 1,000 data for each category. We could compute with more data if we use better hardwares. Also, we can recommend only recent data by sorting the data. We calculated the similarity based on its keyword of title and short description. We also write some code to analyze keywords of articles based on its content to get better data and make better recommendations, but we couldn't add it because of its huge time cost. Our recommendation algorithm need much time to calculate similarity, so users should wait for a long time. If we add user database, we can compute the similarity every time when the user reads new news. Then we can reduce the time to calculate similarity when the user requests recommendations. Thank you for listening.